In this video, we're going to continue discussing increasing and decreasing in function graphs. And so what we're going to focus on particular is we're going to look at the proper notation to describe when a graph is increasing, decreasing, constant, positive, and negative. So let's review a few things before we get too far. So here I have a graph, and I know it's a function because it passes the vertical line test. And we determined that a graph is increasing when it's going up from left to right. So as I read the graph from left to right, it's going up. And I determined that it's decreasing when it's going down from left to right. So in this particular graph, I see that it's decreasing and then it's increasing. And we have these points right here. We'll talk about these points a little bit, but this is where it turns. You can call this a turning point. And so what we described in the last video was where was the graph increasing? And we would say to the right of x equals -2. And what we use is we use the x coordinate to talk about where the graph is increasing or decreasing. Now we do that because in a function, the x's don't repeat, whereas y's can repeat. So for example, if you notice here, this has a y of 0 and this has a y of 0. So I can't use the y's to talk about where a graph is increasing or decreasing because they repeat, whereas x's don't. Now to show where it's decreasing, we're talking about the stuff on the left. So we would say to the left of x equals -2. And so that's where we left off. We talked about left, right, we talked about in between. Now what we're going to look at is the proper notation for how to do this. So we wanted to introduce the concept first. Now let's add some notation. So here's how we do this. We're going to use inequalities to talk about where it is increasing, decreasing, and so on. Now here's a little cheat sheet. So to talk about when you use the word between, we would say x, and then we have these two inequalities here. This is what is referred to as a compound inequality, meaning that there's multiple inequalities happening at the same time. Equality. There we go. So we have a compound inequality. So we say between. So we put the numbers that it's between. Now to say it's the left, we would say x is less than that number. And to the right, we would say x is bigger than that number. So we're talking about all the x is bigger than that number, all the x is smaller, and so on. So this is our little cheat sheet. If I would take a second and copy this down, because we're going to use this in a couple of problems. So let's go back to that same problem, and let's talk about where the graph is increasing, where the graph is decreasing. So remember, we're going to use our x value. So the number that we're looking at here is -2. That is the x value we care about. At least for increasing, decreasing, don't look at -5. So when I'm talking about increasing, we're saying it's to the right. So what we're going to say is increasing when x is greater, so x is bigger than -2. And that's how we say it. So instead of saying to the right, we would say x is greater than -2. And the reason that's true is because if you think about it, what's this x value here? Well, it's -1, and -1 is bigger than -2. If I look here, this is 0. Is 0 bigger than -2? Yes. Over here, I have 1, which is bigger, and so on. So we're looking at all of the x's that are bigger than -2. That's where it's increasing. Now, decreasing, we talked about, is here on the left. So we're talking about all the x's smaller than -2. So you would say x is less than -2. And that's it. That's how we use the notation. Let's do it again, but this time, instead of talking about increasing, decreasing, let's talk about positive and negative. So we're looking at positive, negative just as a refresher. So when we were looking at positive, negative, positive is when the graph is above the x-axis. I'm going to draw a little line here. We're looking at all the parts above the x-axis for positive. We're looking below the x-axis for the negative. So I notice here that there are two positive parts. I have one part here, and I have one part here. So let's deal with this one first. So my x coordinate here, we're going to say it's about x equals -4. About. And we're going to estimate a little bit. That's okay. For right now, we'll get more specific later. But we're going to say all the numbers to the left of -4. So that's the first place where it's positive. So x is less than -4. or I'm sorry, this word is positive, but it's also positive over here on this side. We're going to say this is x is 0. So it's also positive. We're going to say and when x is greater than 0. So we're saying to the right of 0. So this is to the right of 0, right of 0. And this is left of -4. Those are the exact same thing. So I would say this is to the right of 0, this is to the left of -4, and that covers where it's positive. Now, if I'm looking at where it's negative, I see this whole big U shape. Ooh, that's not the best, but you get the idea. So this whole part is negative because it's below the x-axis. Now I have these points I'm going to look at, -4 and 0. So what we would normally say if we weren't using the notation is we would say between x equals -4 and x equals 0. That's what we would say. So to say this using inequalities, we have x in the middle. So x is bigger than -4, so I have -4 on the left, and smaller than 0. Now, if you want to think about it, basically you're just putting the smaller number on the left or the bigger number on the right. So we're saying between -4 and 0, that's where it's negative, and x is literally between -4 and 0 in my answer. Let's do one more. So let's try this one. So I have a different graph. This time we're going to look at when it's increasing or decreasing. So I want you to give this a shot. Go ahead and pause the video and see what you do. Okay, so let's try starting with increasing. So the main thing I'm going to look at is this turning point, and I don't care about the 2 right now. I just care about the 4. The 4 is what's important. So we're going to say that this is to the left. This is where it's increasing. So that would be x is less than 4. So when x is smaller than 4, over here on the left, it's increasing. So that means it's decreasing on the right. So we would say x is greater than 4. And there we go. That's it. That's your answer. X is less than 4. X is greater than 4. I have it smaller than 4, bigger than 4. Now let's try positive and negative. This one's a little trickier because you're going to have to use a between. So for this one, let's say this is approximately x equals 5.5, and we'll say this is approximately 1, 2, x equals 2.5. We'll make it kind of approximate, and that's okay. So try and talk about when it's positive above the x-axis or negative below the x-axis. So let's start with positive. So positive means that it's above the x-axis. So that would be this entire U shape right here. So what we're going to say is we're going to say x, it's between, so it's bigger than 2.5, but it's smaller than 5.5. So it's between 2.5 and 5.5. That covers this entire little U shape is when it's positive. Now for negative, there's 2 spots. So we're going to have an and in the middle. So we'll have one inequality and another inequality. So this first section right here, we're talking to the left of 2.5. So we're saying x is less than 2.5. So all of my x's that are smaller than 2.5, that's where the graph is negative. And also to the right of 5.5. So I would say x is greater than 5.5. And that's it. That's how you use inequalities to describe where a graph is positive, negative, increasing, and decreasing.